Very good afternoon to all of you. I, Sonal Tiwari, research scholar in RIT University, Bhopal. My paper presentation topic is on Deep Machine Learning Tracker for Real-Time Object Detection. Abstract proposes a novel tracker which is controlled by sequentially actions learned by deep reinforcement learning agent. The basic idea is to localize objects in a scene by finding dense regions in the scene and guide the visual attention to that part for detection. During this presentation, I will go through the background and proposed method. During the background, definition of real-time tracking, types of learning, deep learning, reinforcement learning, and during the proposed method, models, problem statement, policy with RL, training and testing, result and discussion. First of all, background. Basically, image classification involves defining class of one object in an image. Object detection is a technology which identifies objects in image. Object localization, the location of the target object is difficult because of several tracking obstacles such as motion, blur, background, etc. Object detection technique often uses expected features and learning algorithms to distinguish instances of an object or images related to an object category. Object detection is applied in several areas of computer vision, including image retrieval, surveillance, security, automated vehicle system, and machine checkup. Basically, we are having three types of learning, that is supervised learning, unsupervised learning, and reinforcement learning. The supervised learning is considered to be the most elementary class of machine learning algorithm. As the name suggests, this algorithm requires direct supervision, and the system is able to provide targets for any new input after sufficient training. And unsupervised learning, in the unsupervised learning, the algorithm tries to learn and identify useful properties of the classes from the given data without the help of intervention of a human. And the reinforcement learning, in this type of learning, the machine is allowed to train itself or continue using trial and error. And the reinforcement learning is the behavior machine learning model that is similar to supervised learning, but the algorithm isn't trained using sample data. And the supervised learning model learns as it goes by using trial and error. Here is the difference between the machine learning and deep learning. Basically, deep learning is the subset of machine learning, and machine learning is the type of artificial intelligence. And machine learning is prepare a training data set using the training subset and evaluation subset. And machine learning training the algorithm to create the model and improving the model. And the deep learning algorithm defines an artificial neural network that is designed to learn the way the human brain learns. And deep learning model requires large amount of data that pass through multiple layers of calculations and applying weights and bytes in each successive layer to continually adjust and improve the outcome. And this is the reinforcement learning. In the reinforcement learning, we having the agent, action, reward, state, and the environment. Basically, agent is the tracker is the agent, and using the successive of continuous actions and states, we can make the environment. And this is the proposed model. Our proposed model is based on Markov decision process, and basically tracker is defined as an agent of which goal is to capture the target with a bounding box shape. The action is defined in a discrete space, and the sequence of action and state is used to iteratively pursue the resulting boundary box location and size in each frame. The agent decides sequential action until finalizing the target position, and then goes to the next frame. And this is the intersection over union. Here S and S dash are the states. Basically IOU-BG is a overlap ratio of the terminal patch position BT and ground truth G of the target, which intersection over union criteria. And this is the problem statement. Basically, our tracking strategy follow Markov decision process, and the tracker is defined as an agent. The action is defined in a discrete space and a sequence of actions. State is used to iteratively pursue the resulting bounding box location and size in each frame. The agent decides sequential action until finalizing the target's position, and then goes to the next frame. And this is the policy with RL. Core problem is to find the policy that guides the decision-making process of this agent. Problem is formulated as a reinforcement learning problem using Q-learning. Approach estimate the action value functions. And this is the training and testing. To perform training testing steps with experience replay method having taken action at time t, and the agent experience is stored in a buffer with the format of ET. The buffer DT is a list of experiences that the agent has faced during its interaction with the environment. And this is a result discussion. Basically, our proposed method precision is 91.7, and our method is comparative with other methods also. And this is the performance evaluation. We evaluated our method on two OTB data set, that is OTB 50, which has 50 video sequences, and OTB 100, which has 100 video sequences including OTB 50, and 360 training videos. And this is the conclusion. We have proposed a novel tracker restricted by the reinforcement learning based novel model, which pursue the target object by sequential actions iteratively. It is the important effort to adopt the tracking strategy controlled by pursuing action trained by deep reinforcement learning. According to the evaluation result, the proposed tracker achieves a state-of-the-art performance in 3 FPBS, which is 3 times faster than the existing deep network-based tracker adapting a tracking by detection strategy. Thank you.